Hi, I'm Stephanie from Design Plus Code. In this tutorial, we're going to learn how to build a media player application. So this is the application we will build, and how this application works is that we're fetching the videos from an API called the Pexels API, which allows us to fetch videos and photos for free and to use them in our application. So right now you can see that my query is nature. So we have a few videos related to nature, and when we click on one of the cards, it will redirect to a view called the VideoView, and it uses AVPlayer from Apple so that we can easily integrate a video in our application. When we change the query to, let's say, animals, it will fetch again the videos, and it will only be videos of animals. And we're doing the same for all the other queries that we have in our application. So we'll see how easy it is to integrate a media player in our application. Before starting to code, make sure that you have at least Xcode 13 installed on your computer, because we'll be using new features introduced in iOS 15, and it's only available in Xcode 13 and higher. After our Xcode project has been created, we'll start building the UI. So we'll code the different components that make up our application. We have a query tag here. We also have a video card, as well as a video view that uses the AV player from the AVKit framework from Apple. Once the UI is done, we'll take care of the Pexels API. So we'll create an account, get an API key, and also create the function to fetch the videos asynchronously in our SwiftUI application. Finally, we'll display all of this data that we fetch from the API in our application. We'll also see along the way how to add dummy data from a JSON file in our application for our previews to work. So let's start straight away. First, let's create our Xcode project. In the model that appears when you launch Xcode, click on Create a new Xcode project. In here, make sure that you're under the iOS tab and select App under the Application section, then click on Next. You need to give your product a name. So in my case, I will name it Video Player Demo. Select your team and fill in your organization identifier, which is the reverse of your domain name. For example, our domain name is designcode.io, so by reversing it, it becomes io.designcode. Then make sure that your interface is SwiftUI and your language is Swift. These are usually the default values, so you don't need to change anything. Then click on Next and select where you want to save your project. Then click on Create. Once our project has been created, the first thing I like to do is to close this panel, and at the top, we'll change our simulator to iPhone 13. Then I will resume my preview to make sure that everything works. Once you see the simulator with the Hello World text on the screen, that means that everything is perfect. Now let's go into our assets folder, and we'll be updating our app icon as well as our accent color. For the app icon, you just need to create an icon for each size that you see here and simply drag and drop the corresponding size in the corresponding slot. Once you're done with the app icon set, let's go to the accent color, and we'll be changing it to a custom color. So you can select any color that you want, but I already have my hex color. So I will click on Universal, then I will open the right panel here. And under color, I will click on Show Color Panel. And under the RGB sliders tab, you can select your custom hex color. So in my case, I will set it to CEDEDE, which is a blue-green color. So this accent color will be the color that we will use for our background, as well as the color of the back button in our navigation bar. Now we will create our first component, which is the query tag. So the query tag is this tag here that you see at the top, and we'll iterate over the different queries that we will hard code in our application. And for each one, we will show a query tag. So back in Xcode, under the Video Player Demo folder, we'll right-click and create a new group. This group will be called Components, and I will simply drag and drop it after the content view. Then I will right-click on this folder and create a new file. This file will be a SwiftUI view, and we'll name it QueryTag. Then click on Create. This query tag will take two arguments. So the first one will be a query, which will be a string, but later on we'll update the query type to something else. And the second variable is called isSelected, and it will be a Boolean. Remember to also pass these two variables in the preview so that we don't have this error from Xcode. So for the query, I will simply write nature, and for the selected state, it will be true. Then in the body of this component, we will remove the hello world inside of the text and replace it with the query that we passed to this function. Then we'll change the font to caption, make it bold, and we'll also change the foreground color. We'll check if the isSelected state is true. If it is, the foreground color will be black, otherwise it will be gray. Then let's add some padding of 10 pixels all around this text, and we'll add a background color, which will be a thin material. So the thin material is like a blur background. And finally, we will add some corner radius of 10 pixels around our component. So you can see that we now completed our query tag. Next, we will want to hard code all the possible queries that the user can select in our application. So let's right-click the video demo player folder and create a new file. This file will be a SwiftUI and we will name it VideoManager. Then let's create it. So this file will contain everything related to the videos. However, before we create the function to fetch the videos, we will create an enum first. So let's create an enum called query, and it will conform to the string as well as the case iterable protocols. An enum is an enumeration of different possible cases. So we'll add 5 cases to this enum. We'll have nature, animals, people, ocean, and food. You can write any query that you want, but I like these 5 queries, so I will keep them. These are the queries that we will pass to the Pexels API in order to search videos related to that query. This enum conforms to the string protocol, meaning that each case can be transformed into a string. It also conforms to the case iterable protocol so that it will allow us to iterate over all the cases in our view. Now let's go back to our query component and we will change the string here to the query enumeration that we created. So that means that what we pass to this component cannot be a string. It should be either query.nature, query.animals, query.people, query.ocean, or query.food. So you can see that we have a few errors here, and it says that our query doesn't conform to the string protocol. And since the text view only accepts strings, we cannot pass the query as is like this. We need to do .raw value to get the exact string of our query enum element. And here for the preview, since we passed the string, it doesn't conform to the query type. So we can remove the string and we'll call our query enum dot and select anyone that you want. So I will select food, and let's resume our preview. And you can see that our query tag content changed to food instead of nature. Now we will iterate over all the cases in our enum, and for each one we'll display our query tag. And since we'll have a few views in our project, it's good to create a group and save all the views under that group. So let's create a new group and we'll call it views. Then we'll drag and drop the content view inside of this folder. And let me just move it after the video player app demo file. In content view, let's remove the text hello world and we'll replace it by a VStack. On the VStack, let's add a background color and we'll use the accent color that we added in our assets folder before. Then inside of this VStack, we will add an HStack and we'll iterate over the different cases in our query enum. So we'll do a for each and we'll call our query.allCases. So it's possible to do .allCases here because in our enum, we conformed it to the case iterable protocol. Then we need to provide an ID, so it will be .self. And we get a search query inside of the loop. So for each search query, we will call our query tag. And remember that it requires 2 arguments, so a query as well as an isSelected state. For the query, we'll simply pass the search query that we get inside of the loop. And for the isSelected state, let's simply hard code a false for now, but we'll update it later on. Now you can see all of our tags here, and it doesn't take the whole screen, but we will be fixing that later on. We'll also take care of the functionality of these tags later on after we fetch the data from our API. Now let's code our video card. The video card is this card here that you see. and it contains the image of the video, a play button on top, as well as the duration and the author of this video. Under the components folder, right-click, create a new file, and it will be SwiftUI view. Then click on Next, and this component will be called a VideoCard. Let's remove the text Hello World in the body and add a Z-stack with an alignment to bottom leading. Inside of this Z-stack, we will call the async image and pass a URL. Let's create a URL from a string, and for now, we'll only add an empty string. We'll also get two closures with the async image. So the first one is to modify the image, and the second one is the placeholder. For the placeholder, let's add a rectangle, and we'll change the foreground color of this rectangle to gray with some opacity set to 0.3. Next, we also have a frame with a width of 160 pixels and a height of 250 pixels. We'll also add some corner radius of 30 pixels all around this rectangle. Inside of the image closure, we will add image.resizable.aspect ratio content mode.fill. We'll also add the same frame that we added in the placeholder, as well as the corner radius as well. So right now, since the string is an empty string, it won't load any image on our card. But that's okay because we will be fixing that later on. Below the async image, add a VStack with some alignment to leading. Inside of this VStack, we will add two texts. The first one will be the duration. So let's simply hardcode 32 seconds for now. We'll change the font to caption and make it bold as well. Great. Below this duration text, we will add a text which will display the author. So for now, we'll simply write by XYZ. And the font will also be caption, a bit bold. And we'll also need to add the multi-line alignment text to leading because sometimes the author name is longer and it will take 2 lines. So we don't want it to be aligned to center. We want all the text to be aligned to leading. Now you can see that the text goes over the card a bit. So on the VStack, we will add some padding all around this VStack. We'll also change the foreground color to white, and we'll add some shadow with a radius of 20 pixels. Now we need to take care of the play button. So click on Command on your keyboard and click on this Z-stack. We will embed this in another Z-stack. So right after this child Z-stack, and make sure that you're outside of the Z-stack, we will add an image from SF Symbols. So we will use the play.fill image, which is basically a play button. Let's change the foreground color to white. The font will be title, and we'll also add some padding all around our button with a background, which will be ultra thin material. So it's a built-in blur background from SwiftUI. And finally, we will add some corner radius of 50 pixels so that it's a perfect circle. So you can't really see it now because we don't have an image yet. But if we take a look at the final results, we can see the blur effect around our play button. Now, there's no data passed to this component right now, but we'll be fixing that now. So we'll put this component aside for a while and code the response body model now, which is the response body that we get in return from the Pexels API. The Pexels API is an awesome API that lets us query free images and videos that we can use in our applications. So let's go to pexels.com/API and then click on documentation. In here on the left side, we'll scroll down and click on search for videos under the videos section. So this is the endpoint that we'll be calling to fetch our videos into our SwiftUI application. In other words, we'll provide a query keyword and the API will fetch videos related to that query. Luckily, we already hard-coded the possible queries that the user can select in our application in our enum query. If you take a look at the documentation, on the right side, we have an example response that is returned when we call that endpoint. So inspired by this response body, let's go back to Xcode and we'll create our response body struct. So we'll code that in our VideoManager file. Let me just drag and drop it before the views folder. Great, so right below this enum query, we will create a struct called response body. it will conform to the decodable protocol, which means that we can decode the JSON into this model that we'll create now. So if we take a look at the example response, we can see that it has a page, a per page, a total results, a URL, and an array of videos. So let's add all of these variables in this response body. So we'll have a page, which is an integer. Then we have a per page, which is also an integer. Next, we have total results, which is again an integer. Then we have a URL, which is a string. And finally, we have videos, which is an array of video. We'll create that video struct right outside of this response body and below it, so struct video. And this will conform to the identifiable protocol, which means that each video can be uniquely identified by its ID. Then we also need to conform it to the decodable protocol because we want to convert JSON data that we get from the API into this video model. Now, if we go back to the documentation and we scroll down to the videos array, you can see that each video has an ID, a width, a height, a URL, an image, a duration, and a user object. And don't forget that we also have a video files array, which is the link to the video file itself. So this is really important. However, there's certain variables that we won't need, like the width and the height. And it's okay if we don't include all the variables that this API returns, because there's no point to add them if we don't use them. It will just waste time. So let's go back to Xcode. And the first argument that we have in our video structure is an integer, which is an ID, which is an integer. Then we have an image, which is a string. Next, we have a duration, which is an integer. We also have a user, which will be of user type. So right below this variable, inside of the video structure, we'll create our user structure, which conforms to the identifiable and decodable protocols. Inside of the user, we'll have an ID, which is an integer, then a name, which is a string, and finally, we have a URL, which is also a string. Now, we didn't finish the structure of our video. Right below the user variable, we also have the video files, which is an array of video files. So we also need to create this video file structure right below the user one. So struct video file, and you will also conform to the identifiable and decodable protocols. Inside of the video files, we have an ID, which is an integer. Then we also have a quality, which is a string, a file type, which is also a string, and finally, the most important one is the link, which is a string. Now you can see that all of our errors has been silenced. Now that we created our response body, it's time to add the JSON file containing the dummy data of one video object, because we'll need to use it in the preview for our video card and see if everything is okay when we will connect it with an instance of a video. So I already created that file and I have it here. You can find it either in the GitHub repository of this tutorial, or you can also find it in the source files. So once you downloaded this file, simply drag and drop it into the preview content folder and leave all of these options as is and click on finish. If we open this file, you can see that we just have one object and it has an ID, a URL, an image, a duration, a user object, as well as a videos files array. So that follows the exact structure of our video structure that we created in our VideoManager file. Next, we'll need to create the load function that will load the JSON data and decode it into the video model that we just created. So under the preview content folder, right-click, create a new file, and it will be a Swift file. This file will be named model data and click on create. You can head over to this section of the SwiftUI Advanced Handbook, and you can find this link in the description below or in the text content of this section. If you scroll down to the middle of the section, you will find this load function here. So simply copy everything here. Then back in Xcode, we'll paste this function. So this is the load function that will take a JSON file and then transform the content of the JSON data into the model that we will specify when calling this function. However, we need to update this function by adding just one line of code. So after creating a JSON decoder instance, add a new line and call the decoder.keyDecodingStrategy. It will be equals to convert from snake case. If we take a look at the example response that we get from the API, you can see that our variables are all written in snake case. However, in our structure in Xcode, we wrote all of our variables in camel case. So that will let the JSON decoder know that we want to convert all the snake case variables returned from the API into camel case variables. Then, right before this function, let's create a global variable called preview video. And it's important to specify the type of data that you want to convert the JSON data into. So in this case, we want to convert that into a video structure. Then equals, we call the load function, and we need to pass a string, which will be the file name of our JSON data. In this case, it's the video data file. So we'll add videodata.json. This variable will be available everywhere in our application. So to make sure that everything runs smoothly, you can do Command B on your keyboard and it will build your application. So you can see that my error that I had here has gone away and my build has been successful. Now that we have this variable, we can go back to the VideoCard component and update this by calling the preview video variable and passing it to our preview in VideoCard. So at the top of the VideoCard component, add an argument, which will be video, and it will be of type video. You will see that Xcode is complaining that we didn't pass a video to our preview, so we'll pass one, and we'll call the preview video that we just created in our model data file. Now, if you resume your preview, you'll see that our card stays the same as before. That's because we didn't call the variables from the video argument that we passed to our VideoCard component. So the first thing we need to do is to change the image. Instead of an empty string, we will call our video.image. And you can see now that we have the image of our video. Next, we need to update the duration. So let's remove the 32 seconds and add a string interpolation, then called video.duration and add the seconds afterwards. Since the object in my JSON file is also 32 seconds, my video card will also display 32 seconds. Finally, we need to update the author of the video, so let's remove XYZ and add string interpolation, then call video.user.name. Great, now that we have our video card, let's go to content view and we'll add the card here. And we'll just add one instance of a card here, but we'll update that later on and iterate over all the videos that we get from the API. Below the H stack, add a new line and then add a scroll view. Inside of this scroll view, we will call our video card and we need to pass a video to this video card. So for the moment, let's simply pass the preview video variable that we created. And you can see that it doesn't take the entire width of the screen. So we can add a frame to our scroll view and the max width will be infinity. We'll update this scroll view later on with a lazy V stack once we fetch the data from the API. Now it's time to create our video view and we'll learn how to use the AVKit framework from Apple to easily integrate a media player in our SwiftUI application. So under the views folder, we will right click, create a new file. It will be SwiftUI view and we will call this file VideoView, then click on create. This view will accept one argument, which is also a video, and it will be of video type. Remember to pass a video to the preview so that Xcode doesn't complain. So video, and we'll call the same video that we used in our video card, which is the preview video variable that we loaded from our JSON file. Then at the top of this view, we will need to import AVKit, which is a framework that is built in SwiftUI, and you don't need to add any package in your application. Then right below our video argument, we will add a state, private var, which will be called player. And it will be equals to an AVPlayer with parentheses at the end so that we initialize an instance of that player. Then in the body, let's remove the text hello world and we'll call our video player. The video player is a view from the AVKit framework and it's basically just a video player integrated in your SwiftUI application. This video player requires a player as an argument and you can see that it's of AVPlayer type. So let's pass the player state that we have on line 13. And you can see now that we have our player displayed in our preview. However, you can see that the top portion and the bottom portion are white. So to fix that, we will add the edges ignoring safe area dot all modifier so that it covers the entire screen, even the safe area. However, right now, when we play our preview and try to play our video, nothing happens. That's because we didn't add the link to our video file to this video player. So on up here of this view, we will add a URL to our AVPlayer. To access this link, we need to call our video.video files. And since the video files is an array, we will take the first one and then get the link of that video file. However, by doing dot first, you can see that it's an optional. So let's add a question mark after first, and we'll need to unwrap that optional. So we'll do if let link equals to video.videofiles.first.link. Then we'll reassign our player state. So player will be equals to AVPlayer, and we'll provide a URL. Then we'll need to create a URL from a string, and we'll pass the link state that we unwrapped on line 19. And by creating a URL this way, it might be optional. So at the end, we will add an exclamation mark. And you can see that my preview updated and we see the preview of our video. When the user lands on our video view, we also want to automatically play the video. So luckily there's a simple function for that. We'll call our player again, .play. So let's pause this preview and play it again. And you can see that it refreshes and the video has automatically started. Great, now we're done with our video view. We'll link this view to our video card later on. But first, let's dive into the Pexels API and generate an API key so that we can fetch the videos from our API. Now head over to pexels.com/API and click on the Get Started button. You will be redirected to this page here that asks you to join Pexels. So we need to create an account in order to get an API key to use the API. I suggest you to avoid joining with Apple because I tried it and there are some issues related to that for the moment. You'll always be redirected to your profile after signing in and you won't be able to generate an API key. The safe way to go will be to create an account with email and password instead. Once you're signed in, you will be redirected to pexels.com/API/new. And you will need to fill in a form with some easy questions to generate an API key. Then you will see your API key here and you can copy it because we'll need it when we'll create our HTTP request function in a few moments. It's also important to note that this API has a rate limit of 200 requests per hour, and sometimes Xcode's preview can update many times, so we might go over that limit fast. Therefore, make sure not to call the API too many times because if you reach the rate limit, you might run into a failed build every time. In this tutorial, as I mentioned before, we'll be calling the search video endpoint that allows us to query some keywords, for example, nature, tigers, people, or group of people working, and search for videos corresponding to that keyword. You can also see the list of all the parameters that you can add to your API call. So we will use the query and we'll also use the orientation because we want to fetch videos that are only in portrait mode. Now we'll create our VideoManager class as well as the HTTP request function to asynchronously fetch our data from the API. So let's go to our VideoManager file and I will add this after my enum and before my ResponseBody struct. So I will create a class called VideoManager which will conform to the observable object protocol. Inside of this class, we'll create two published variables. So the first one will be private set because we only want to set this variable within this class. It will be called video and it will be an array of video. By default, we'll set it to an empty array. The second published variable will not be private set because we'll need to update that outside of this file. And we'll call it selected query, which will be of query type, which is our enum that we created before. And by default, we'll set it to the first one, which is nature, but you can set it to whichever you want. Next, we'll code the find videos function. This is the function that will fetch the data from the API and convert the JSON data into the ResponseBody struct that we created before. So func find videos, and we need to pass a topic, which will be a query. So it should be one of the 5 cases in our query enum. Remember that this function is asynchronous, so we need to add the async keyword right after the parentheses. Inside of this function, let's add a do catch statement because we want to catch any error that might be thrown within this function. So if we run into an error, we will print error fetching data from Pexels, and then we'll print the actual error. In the do, the first thing we need to do is to create our URL, but we want to make sure that we have a URL before running the next line of code. Therefore, we will add a guard statement. We'll do guard let URL equals to a URL, and we'll create a URL from a string. Else, we'll throw a fatal error, and it will say missing URL. We need to add a string here for our URL. Let's go to the Pexels documentation, and on the right side, you will see here the link that you can copy. So we'll copy this, go back to Xcode, and paste it between the double quotes. However, we'll update this URL. So first, we don't want to just query nature videos. We want to query the videos according to the topic that we pass to this function. So we'll remove nature, and we'll add a string interpolation. Then we'll call our topic variable that we pass to this function. And we don't want just one video returned per page, we want 10, so we'll add 10. And we'll also want to specify the orientation to be portrait mode, so all of our videos are in portrait mode. To do that, we'll add and, then we'll write orientation equals to portrait. Great, now that we have our URL, it's time to create a URL request. So we'll do var URL request equals to a URL request, and we need to provide a URL to our URL request. So luckily we created that on line 20. If you remember, this API requires an API key. So we'll call our URL request variable and set a value. And it will have two arguments. The first one will be the actual API token, and the second argument you'll need to specify for which HTTP header field that you want to add this value to. In our case, we want to add this to the authorization header. Remember to paste your API key in the first argument of the setValue function. Once this is done, we will need to call the data. To call the data, we'll do URL session.shared.data for the URL request variable that we created on line 22 and updated on line 23. However, this function is asynchronous and might throw an error. To fix that, we'll add try await before, and it will return us two arguments. The first one is the data, the actual data that we fetch from the API, and the second one is the response, which tells us if the fetching was a success or a failure. So let's save that in a data as well as a response variable. Then we'll need to make sure that the status code from the response is 200 OK, meaning that everything is OK. So we'll do guard response, and we want to check if it's an HTTP URL response. If it is, we'll check its status code and make sure that it is 200. Else, we'll throw another fatal error, and this error will say error while fetching data. Now, if we pass this guard statement, that means that everything is fine, and we just need to decode the JSON data that we get into the ResponseBody model that we created here. To do that, we'll create an instance of JSON decoder. So we'll do let decoder equals to JSON decoder with parentheses. Then, similar to what we did in our model data, we need to define the key decoding strategy to convert the variables returned from the API that are in snake case into camel case variables. So we'll do decoder.key decoding strategy equals to convert from snake case. Then we'll try and call our decoder.decode function. The first argument is the model into which we want to decode our JSON data. We want to decode into the ResponseBody.self from the data variable that we get on line 25. Now this will return us something, so we can save that into a decoded data variable. And finally, we'll simply need to assign the videos from our decoded data into the videos array variable that we created on line 15. So we can do self.videos equals to decoded data.videos. We might call this function multiple times because when the user switches their query, we want to reset the videos array before setting it again. So right before that, we'll do self.videos equals to an empty array. Let's call the findVideos function on initialize of this class. So we'll add an init, and we also need to add task.init inside of the init function because findVideos is an asynchronous function. So let's call this here, and remember that we need to pass a topic, which will be of query type. So we'll pass our selected query state, and since this function is asynchronous, you will see an error from Xcode that we need to add the await keyword in front before calling this function. And you can also see in this function that we reset the videos array before assigning it again. That's because when the user changes the selected query, we'll need to call the findVideos function again. So we want to repopulate the array with the right videos related to the selected query. So let's take care of the functionality inside of our VideoManager now. Right after assigning the selected query, we will add a closure. And inside of that, we'll call our didSet. The didSet is called whenever the variable has been set. And when we set the selected state, we want task.init, and we'll copy this line inside of our init function and paste it here. So that means that every time the selected query changes, we will refresh the videos from the API. Let's initialize our VideoManager class as a state object in Content View. So let's go to Content View, and before our body variable, we'll create a state object var VideoManager will be equals to VideoManager with parentheses at the end so that we initialize an instance of VideoManager in this view. Now we want to see if we do get the videos we fetch from the API. So instead of showing one video card inside of the scroll view, we will iterate over the array of videos from the VideoManager. So we'll do for each, and we will call our VideoManager.videos. We need to provide an ID, so it will be .id, and inside of the loop, we get a video. We'll need to add the label for each video that we iterate on. So we'll call our VideoCard, and remember that it requires a video, so we'll simply pass the video that we get inside of the loop. Also, when the user taps on the VideoCard, we want to redirect them to our VideoView. So we'll add a navigation link, and it has two closures. The first one being the destination, and the second one is the label. Let's move the video card inside of the label, and for the destination, we will write VideoView, and we'll pass the same video that we get in the loop. Since we're using a navigation link here, we need to wrap our entire body here in a navigation view. So on the Z stack, click on Command on your keyboard, and then click on the V stack, and embed this in any stack that you want. Then change this stack to a navigation view instead. If you don't add this navigation view here, you won't be able to navigate from one view to the other. Now let's resume our preview, and remember to press on play here so that it fetches the video. Right now you can see that we have a lot of white space at the top of our view. So to fix that, right after our background color, we will call our navigation bar hidden and set it to true. Great. Now we have one other problem. It's that our scroll view displays all of our video cards vertically in one row. We will want to display them in a grid layout. So at the top, create a columns variable, and it will be an array of grid item.adaptive. The minimum will be 160 pixels, and we don't need the maximum, so we'll remove that. We'll also need to provide a spacing argument, which will be of 20 pixels. Then in the for each here, we will embed this in any stack, but we'll change this stack to a lazy vgrid. Remember that you need to provide a columns variable, so we'll provide the columns variable that we created on line 12. Then we'll also add 20 pixels of spacing. If you resume the preview, you can see that all of our cards are here and displayed nicely. However, it's a little bit too close to the sides of the frame, so on the lazy vgrid, we can add some padding. Great. If the videos array is empty, meaning that we're currently fetching the videos, we'd want to show a loading indicator. So inside of the scroll view, let's add an if statement, and if VideoManager.videos is empty, then we want to show a progress view. Otherwise, we will want to show our lazy vgrid. Remember that the preview updates a lot, so you might easily reach the 200 limit per hour. Sometimes remember to pause your preview so that it doesn't always call the API. Now let's take care of the query tags functionality. When the user taps on the query tag, we want to update the selected query variable in our VideoManager. So in content view, on the query tag, let's add the on tap gesture. And on tap gesture, we want to call our VideoManager dot selected query equals to the search query that we get inside of the loop. We'll also update the is selected, and we will check if the VideoManager dot selected query is equals to the search query that we get inside of the loop. So you can see that by default, our selected query is nature. So nature is now in black and the rest of the text is gray. Great, we've finished building our application. So let's build our application in the simulator to make sure that everything is okay. I have my application here and you can see that by default, it selected the nature query. If we switch to another query, let's say animals, you can see that we have all the videos related to animals. And we can test out the other queries as well. So people, and we can see people here. Then ocean, so we have videos of the ocean. And finally, we have food, and great. So the function that we created to fetch the API related to the topic that we selected works. Now, when we tap on one video, it redirects to the video view and it automatically plays the video. However, if we go back to Xcode, you can see that we have a bunch of warnings here. So the first one is that publishing changes from a background thread is not allowed. To fix that, let's go to the VideoManager, and you can see that here we're publishing on the background threads. So to fix that, we'll add dispatch queue.main.async, and inside of the closure, we will move these two lines of code. If you try to build your application again, you won't see this warning anymore. Next, after publishing the values warning, we also have another one which is related to CA transform layer. So this seems to be a bug with Xcode, and it's not really possible to fix it, so we can disregard these warnings for now. Congratulations! You just coded a video-based application from scratch. In this tutorial, we learned or reviewed how to call an API asynchronously, add an authorization header, and decode the JSON data that we fetch from the API into our SwiftUI model. We also learned how to add dummy JSON data into our application and convert it into our model using the load function. Moreover, we learned how to use AVKit, the Apple framework that lets us easily add a media player within our application. I hope that you enjoyed coding along and learned a lot from this tutorial.